these little critters called sea monkeys, also known as brine shrimp, or more scientifically for my research project, Artemia franciscana, reside in ponds in a place called Lac du Bois Grasslands Park, which is just north of Kamloops, BC. In places like Lac du Bois, when ponds dry up, the brine shrimp are forced to go cryptobiotic. In other words, they undergo cryptobiosis in unfavorable conditions such as their ponds drying up or it being extremely cold, and they'll often shrivel up or lay eggs that can stay dormant and survive for years or even up to centuries. So, the eggs obviously can't crawl, but they can fly. Well, they don't have wings, but with the help of a bit of a gust of wind, of course, they can fly. So, even though they're dried up, these babies still need to spread the species, or as we biologists like to call it, disperse. So, the purpose of my project was to find the speed of these wind gusts that are needed to make these suckers fly and disperse. First, I did a bunch of field tests. I set out a bunch of trays out in Lac du Bois Grasslands Park with sea monkey eggs. Later, I went back to see how many eggs flew away. To measure the wind speed out there, I used these cool gadgets called anemometers. Then, I wanted to do some tests where I could actually control the speeds. So, I did the same thing in a wind tunnel to measure how many sea monkey eggs flew off by taking videos like this. And these are my results. This graph basically shows that the brine shrimp eggs need a gust of at least 6 kilometers per hour to even disperse. Then, after about 20 kilometers per hour, we get 100% dispersal. Now that I know this information, I can predict basically how often these sea monkey eggs disperse. And I can even go back and see how often they dispersed in the past using airport wind data. And that is how you make sea monkeys fly. The end.